Hi, we are the BLUElab Hagley Gap team, and I am Brianna Fairchild. I'm the project leader from the previous year and currently.
And I'm Sonia. I'll be the project leader for next year.
As an introduction to our team, I know it's kind of long, but we have our mission statement here. To bring together students of many different engineering and non-engineering backgrounds in the process of understanding the needs of our community by designing, testing, modifying, and implementing our designs effectively. We seek to incorporate education, sustainability, creativity, and collaboration into our designs and team efforts in order to improve the lives of the community members of Hagley Gap and in positive ways. Therefore, we will provide technical and real-world skills to student members while providing meaningful and lasting connections between Michigan students and the people of Hagley Gap. Our team has been working with a small community in the Blue Mountains of Jamaica called Hagley Gap. There are about 5,000 inhabitants. The one special thing about the community is that they do not have access to drinking water or wastewater treatment systems. And so we've been working with the Blue Mountain Project, which is the local nonprofit there. They have a local health clinic, and they also run educational and water-related projects through the use of volunteers in the community. And we've been traveling there for about 8 years now. That's a little background about us.
So in past years, the original problem that we had been trying to tackle was the lack of safe water quality in the Gap. And the solution that we came up with to this was a biosand filter that we, year after year, would design and improve and implement in the Gap. But every year we would find that there was very little community acceptance to this technology. So this year we decided to completely rework our approach, and we really wanted to avoid fitting a solution to a problem that we saw, and we wanted to directly work with the community to identify and solve a problem that was truly important to them and one that they would feel invested in to use and maintain for years and years to come. So just to give you an overview of what we'll be talking about today, this past year, first semester started out with a lot of ethnographic research and needs assessment to get to know the community a little better than we had before. We then split our team up into 3 task groups: dishwashing, hand washing, and drinking water. And then we reevaluated our goals as a team and made some modifications to our approach. And then we just recently came back from our spring break trip to the Gap. And this year, for the first time ever, we'll be taking 2 trips. So we're going to return to the Gap in August again for implementation and feasibility testing.
So as Sonia mentioned, we did a lot of ethnographic research earlier this year. We wanted to really understand the community more and learn as much as we could before going into a project. So we identified 5 main categories that we felt would directly impact their daily lives. So we took a look at family life, including family structure and gender roles, and how that would affect their daily tasks. We looked at core values and what things are most important to that population. We looked at health and healthcare. How accessible is it? What are their methods, and how do they view healthcare? And we looked at the environment and how living in a mountainous region might affect their daily lives, and also local organizations and other groups that might be working with the community other than ourselves. To do this, we mainly used online research and as many resources as we have here in Michigan by interviewing faculty members in the engineering and anthropology departments. And we also communicated with Hagley Gap community members through Skype phone calls and through email. And we also sent written surveys for the kids at the schools to take and send back to us. And those received surveys held a lot of information in them. So when we did our ethnographic research, we realized that we wouldn't be able to identify a problem necessarily from the community without traveling there, but that was going to be all the way in spring break. So in the fall, we wanted to still use what we had learned and do something with it and get going with the design process. So we decided to identify multiple problems that we saw from what we learned and then narrow them down to a specific problem, population, and location where we could potentially solve the problem. So we ended up with the target problem of water quality, with the target population of children or students, and located at the Minto and Penline schools, which are the local schools in the area. And in doing so, we decided to take a holistic approach to this problem and location by considering all of the water uses at the school. So we identified dishwashing, hand washing, and drinking water as the three main water uses that we could explore and possibly design for. And so we broke into task groups based on those categories.
So with each of those task groups, we began the design process, and each task group researched their topic thoroughly, identified a problem that may pertain to the gap on their topic, and then developed criteria for several solutions that could potentially solve that problem, which we then narrowed down to one technology for each task group that we felt could really solve that issue in the gap. But we did recognize that that the community may not necessarily recognize any of these three problems as problems they would want us to help solve. But we wanted our team members to go through the design process and have the experience of understanding what the community was like, what these topics were, and to really become experts on the target location that we were trying to help out. So we did create visuals to connect with the community and to just show them that we had been working on potential solutions if they did recognize any of those three or all of them as a problem that they would like to help us solve. So then we also planned for testing and prototyping afterwards. So our first task group was dishwashing, and they identified a big problem in the gap as germs that were being spread through washing dishes with dirty water and drying dishes with dirty dish rags. So the solution that they came up with was a dish drying rack, as you can see here, that's made out of mostly wood and PVC that's cut into slits for the dishes to hold. And then on the bottom layer, there's a mesh to hold cups and utensils, and then water could drain through that mesh as well. But they did realize that the community may see that this technology would be helpful, but not necessarily a top priority for them. The second task group was the hand washing group, and they identified the problem of lack of functional sinks for washing hands at the schools. So the solution that they came up with was a hand washing station that's serviced by a foot pump connected to a water tank that then brings water to a sink that we were hoping to build out of cement, because that's a very commonly used material at the Gap. But we did realize that the community might see this pump system as a technology that they're not necessarily interested in, because it would have to break their normal hand washing habits. The third task group was the drinking water group, and they have identified two big problems with drinking water. The first was that illnesses were being contracted from poor quality water, especially because we were targeting children. This was extremely important to resolve. And the second was that it was extremely expensive to truck water from the river every day for the schools, because there was no clean running water at the schools. And the poor quality water was a result of uncovered rainwater, which attracted insects. So the solution that they came up with was a rainwater catchment system with a first flush design where debris would drain down the vertical pipe, and then the filtered water would be held into the tank and then fed into the school directly. But they did realize that rainwater may not be a reliable source of water that would fulfill the school's water needs throughout the year.
So at this point in time, towards the end of the fall semester, we'd come up with these designs, and going into the spring break trip, we wanted to reevaluate our goals. And so we made a few changes to our approach. Instead of just giving solutions like we did with the biosand filter, we wanted to do it differently. So we realized that we really wanted to build up our relationship with the community and make it more personal and really get to know them and get them to know us. And so that's why we decided to have 2 trips in 1 year, the spring break trip and then the upcoming summer trip, to make our presence in the community more common and more reliable. We also did not want to repeat mistakes that we had made by making assumptions about the community. Sort of like the biosand filter, we assumed that that would be the best technology for the community. And so this time we wanted to get their raw input before we stepped into the equation. So we wanted to take an interviewing approach by asking them for their input with using open-ended questions such as, what is the most difficult task during your day? They can respond however they felt necessary. And questions such as, like, what do you value the most? What is the biggest problem that you see in the community? And putting the focus on them. We sort of use this two-step dialogue process, whereas we would have the conversation with their input and their opinions first, and only at the end of the conversation would we then tell them about the designs that we've come up with, and just to show them that we've been working on these designs throughout the year, and just ask for their feedback, like looking at this picture of this design, what do you think? What do you like about it? What don't you like about it? And in that way, we avoided survey bias because we were not pushing them for any certain response. And but at the same time, we were able to gain feedback. And like I said, we were placing high value on asking for their input so that we can build a partnership to design with them instead of just offering solutions to them. So in practice, when we went on our spring break trip, we did conduct lots of interviews. We talked to community members, our host families, the schools and the principals, and we learned a lot, and we did gain feedback on our designs, which helped us plan with the schools for what we could do the next time we visit. And while we were there, we also held lesson plans for the children at the school to reinforce education about these water topics. So we did a design process activity, a dishwashing relay race, and a water cycle activity about rainwater. And we also took many pictures and measurements and documented a lot of information to help us continue designing for the rest of the semester.
So from our trip, we learned that the schools definitely view water access as a problem. When we were talking to and working with the Minto Primary School, they expressly stated their desire to have rainwater collected without dust from the roof. And so our first flush system really appealed to them, and they were extremely interested in having us work with them on this design and implement it at their school over other options. And then the Penline Primary School was already collecting water, but they had talked to us about how they don't have any working sinks and how they would really like to enforce hand washing at the school, which was perfect because we were already working on a hand washing station. And so they actually already have a broken down hand washing station at the school, but they were asking us for our help and our input in reinstalling and improving that station at their school. And both of the school's kitchen staffs really loved the dish drying rack design because they felt like it would really simplify their dishwashing process and improve the quality of the dishes that they clean. So overall from the trip, we learned about the community's wants and needs through our intensive ethnographic research and our interviewing with the school faculty and the community members. And we understood and recognized that that past problem that we were trying to solve of water quality was not as big of a concern as this new problem of easier access to water, which most community members and especially the schools saw as a major priority. So now we see the schools as our design partners for these specific projects, and we will continue to and have been working with them on getting their feedback on what they really want on our designs and their input on what they want changed so that they'll feel truly invested in our technology when we actually do implement it. So with them, we've decided that we'll continue with the rainwater collection system design and the dish drying rack designs, but we will be holding off on the hand washing station design until the fall just because we would like to obtain more information in terms of feasibility once we return over the summer. We also did check on the biosand filters from our past trips and trained the nursing staff at the local clinic where we do have one biosand filter that's still working, just to encourage its use.
And so we did take the information that we learned and their feedback over the trip to make a few modifications to the designs to tailor it to what they really wanted. And so on the left is a picture of the kitchen area where they actually already have space where they would be willing to put the dish drying rack. And their process right now is they put their dishes into a cabinet, as you can see in the right photo, a cabinet like that, and then they close the doors when they let them dry because they don't want bugs getting onto the plates and dishes. And so obviously that cuts off the air from drying the dishes, and it could cause stagnant water to sit on the dishes. And so they really liked our idea, but they really wanted a cover to keep the bugs out. So we're going to be adding a screen of some sort to our design and making sure that we size it correctly for the space that they have available. And they also did want it to be portable, so we're going to be looking at a different materials for that. With the rainwater collection system, this is the school, and you can see the downspout coming down from their existing gutters, and then they placed the tank there fairly recently, but it is in place because they would like to connect the gutter to the tank, and then the small white pipes go into the building into the kitchen sink. So basically we just need to connect everything up. This is the first flush system that we originally were thinking of. You can see the ball that rises with the water, which catches all the debris underneath of it and allows the clean water to flow over it. So that didn't need too much modification, but we did come up with another idea. One of our members worked on another project over spring break, and they used a series of filtration. It seems similar to what the LBC team had in their gutters. So we're going to be looking into that and seeing which one is less maintenance and which one works better and would fit the school. And lastly, as Sonia said, the hand washing station we're holding off on until later so that we can do more feasibility and measurements and talk to them more about exactly what they want. But this is what's in place right now. As you can see, it's going to need a little bit of reconstruction. It'll need a lot more new piping, and we want to make sure that the hydraulics are correctly installed. So that will be taking place later on in the summer.
So our summer trip will take place in August, as we had mentioned earlier, and it will most likely overlap with the Fun Camp, which is what BMP puts on every year for the kids. And so that'll be really great for us to be able to volunteer at and continue that educational component every year and do some fun educational workshops about water quality, water hygiene, and just things like that. We also, of course, plan to install the rainwater catchment design system before the school starts at Minto. And we also plan to set up dish drying racks at both schools as they had asked for. And we also hope to teach several community members, or as many community members as we can, about how to build those dish drying racks, since it is a fairly simple process, so that they can hopefully replicate our design in their houses and in other facilities in the community as well. And then the hand washing station will be in the feasibility gate for our next trip. So we will be measuring and designing at the Penline School for our hand washing station. So for our next steps, from March to June, we'll be prototyping and building at the Wilson Center on our rainwater catchment system and our dish drying racks. And then in July, we'll be preparing for our summer trip, which will take place in August. And then we'll return to Jamaica to implement our rainwater catchment system design, our dish drying rack design, and do some feasibility testing on the hand washing station.
And we'd like to thank you all for listening, and we're happy to take any questions and comments that you might have.
So, as far as the design process that you had listed in our earlier slide, were the problems identified based off surveys, those three problem identifiers?
The 3 task groups that we created. So they were created based on when we did our ethnographic research. We came up with different problems, like water quality was one problem, maybe transportation and roads was another problem, different problems. And when we ranked them all, water quality came out as the highest ranked problem. And from there, since we identified our location and audience, that's where we saw like how do they use water at the schools, how they wash their hands. We also looked at flushing toilets and drinking water. And so it kind of went through that process of narrowing things down, and the problems that we were looking at, the water quality problems for the uses. So that's how we identified them.
So as far as like you're saying, so water and construction and other things, so how were those problems identified?
That was through our ethnographic research, just looking at, okay, what do they have to deal with? What are the different factors in the culture? We didn't have community people telling us there are these problems. It was just the best that we could come up with that might exist in the community.
Okay.
And so like as we were designing, we understood that these might not actually be problems in the community, and that we would have to wait until we travel there to find that out.
Okay.
Yeah. No. Do you want to plans?
Yeah, I think just because we will be traveling in August, it'll probably depend on team availability, but they do, hopefully, we usually try to bring back at least one person that has traveled there before, so hopefully we'll still be able to maintain that like recognition with community members that we had met over spring break. And they do sort of recognize us as a team there, so they're very aware that the Hagley Yep team comes every year. So it'll be nice to have that community relationship continue to build.
I really loved your graphics. So I was wondering which program you did those in. And I have another real question too.
Yeah, so Chris actually did those. Do you want to?
Yeah, it's all Rhino.
Yep.
What? It's like architectural design, but I'm doing 3D modeling software.
You guys stream that Rhino really well.
Yeah, I can send you Chris's email if you want any help with that.
And I had a question about the dish drying rack. I know you guys have worked on SODIS, which is solar water disinfection. And I also saw a documentary about how they live in Amish communities and they put their dishes outside to dry so the sun disinfects them while they're drying. And that seems to work really well. So I was wondering if there was any scope to move that outside or whether that would be a problem.
Yeah, I think we kind of wondered that as a team, like, would they want it outside or inside? Because we weren't sure if there would be space, like, inside the kitchen. And so when we talked to the kitchen staff, we asked them, like, do you want to be able to move it around? And they seemed to like the idea of being able to move it. I know that at the Minto school, sometimes the children help they wash their own dishes. So I think that it would be very viable to make it portable so that they can move it outdoors and have the kids load it up and maybe let it dry. I think that we might want to look into, do they perceive indoors as keeping dishes cleaner? Like, would they, if they had it outdoors, would they see it as the dirt and wind kind of making it dirtier? But I think that if we educate them on the UV power, then maybe they would be more open to that as well.
Thank you.